We're going to spend some time now looking at branched alkanes, which is a more common form of the alkane family. Most alkane molecules, or any organic molecule for that matter, contain branches. And they are not just straight chains like we have seen in the previous lesson. So branches will be obvious on your organic molecule because you're going to notice that there are little carbons sticking out from the main straight chain. And these branches are called alkyl groups. Okay, that's the term for them. And it says there it's a hydrocarbon group derived from an alkane by the removal of a hydrogen atom. So for example, we know that the alkane molecule methane contains 1 carbon and 4 hydrogens. Okay, so this is our alkane that is called methane. If we remove one of these hydrogens and we just have that electron that is not bonded to anything, this structure right here can now be bonded into a straight chain molecule. Okay, so it could go right here and it could be bonded in as a branch. So when you have these alkyl groups or these branches, you would name them based on the root word for the number of carbons. So if you had a 1 carbon branch, we would call it a methyl group. If you had 2 carbons that was attached as a branch, we would call it an ethyl group. 3 carbons would be propyl, 4 would be butyl, and so on. So we don't call them a methane group because methane is its own molecule. But once the hydrogen is removed and the methyl is attached as a branch, we then use this YL suffix from the alkyl group and we call these branches by this name. When we first start to name alkane molecules, the nomenclature rules might look a little long and overwhelming. The good news is once you learn these rules, you will be applying these rules to every single family that we're going to learn in this course with some small exceptions. So for example, the suffix, okay? We know right now we're dealing with alkanes and the alkane suffix refers to single bonds. That suffix is going to change, so nomenclature will change based on what the suffix is indicating about the functional group. But for now, we want to know just the basic rules for naming an alkane molecule. And you'll see the rules here. They're at the top of your note. I'm going to go over a couple things right now, but we'll touch on these rules as we go through the examples. The biggest part and most important is to find the longest carbon chain. So the longest carbon chain sometimes goes straight across the molecule, but remember that sigma bonds have some flexibility to them and they have rotation. So sometimes the longest chain can rotate and kind of zigzag across the page. When we are looking at these alkane structures, if there are branches, we're going to start numbering the carbons starting at the carbon closest to the first branch. And from there, there are some extra rules that we will touch on as we move through these examples. So let's get to a couple of easier examples to start. Okay, so let's look at this first example here on the left. And what we want to do, we can tell that this is a branched molecule because I can see that I have carbons going across right here. And then I notice I have this branched alkyl group attached in. And you may want to do this, okay? Find your longest chain. Remember, this is rule number 1, find the longest carbon chain. And then find any branches that are attached to it. And I like to circle my branches. I like to box out my longest chain. So the longest chain of carbons is 5 going straight across. So 1, 2, 3, 4, and 5. And then we want to number this longest chain. And remember that rule number 2 says to number the chain from the side closest to the first branch. Well, if we start numbering carbons here, so this would be carbon 1, 2, 3, I get to my branch. I could also go from the other side. 1, 2, 3 also gets me to this first branch. So what's happening here is that it really doesn't matter what side I start numbering my carbon chain from, because that branch is smack dab in the middle of the molecule and it won't matter anymore. So let us resume back here, clean this up a little bit. So here is my longest chain, and I'll just start numbering from this side. So 1, 2, 3, 4, and 5. Okay. The reason that we want to number the longest chain or the parent chain is because I have to tell you the location of this branch. Okay. Now this is a branch right here. It's an alkyl group. It's a 1 carbon alkyl group. So we know that a 1 carbon group is called a methyl. And this methyl is sitting on carbon 3 of my parent chain. So when we set up the name, we put the prefix first, which is the branches. That methyl is sitting on carbon 3. So we write 3-methyl. And then we write the root word of the longest chain. So we have 5 carbons. The root word is pent. And then we want the suffix for this family. Everything is single bonded. Suffix is -ane. And so my structure is called 3-methyl pentane. Let's look at the next one. So the next molecule over here on the right, I need to find the longest carbon chain. So I can go 1, 2, 3, 4, 5, going straight across. That works. I could also, let's get rid of those. I could also start at the top here. 1, 2, 3, 4. Okay, that would be an example of a chain, but that's only 4. 5 is better. I could also do this. 1, 2, 3, 4, 5. Okay, so right now I have 2 different versions that have 5 carbons as the longest chain. And what I would likely do is just in that case, I'm going to just go straight across to get my 5 carbons that way. I have 2 branches. You can see them. There's one there. There's one there. They are both the same kind of branch. They are a 1 carbon branch. 1 carbon branch is a methyl. I'm going to number this chain from the side closest to the first branch or first alkyl group. So this side over here, 1, 2 carbons takes me to the first branch. If I went from the other side over here, it would be 1, 2, 3 carbons until I get to the first branch. So we do not want to do that. Okay, we're going to start from the other side and we're going to keep numbering. So we have 1, 2, this is carbon 3, 4, and 5. So we want to write down the prefix, which is the branches. And I have 2 of them. So when we have 2 branches or 3 branches, we use a prefix to indicate that we have multiples. Each of these branches are sitting on carbons 2 and 3. So we write those location numbers with a comma. I have 2 methyl groups, so we're going to use the prefix dimethyl. I think this is rule number 4, I think, in your nomenclature rules. And then that's it for branches. Now I name the parent chain. So the parent chain is 5 carbons, 5 carbon prefix, or sorry, root is pent, all single bonded, pentane again. So this is a 2,3-dimethyl pentane. Okay, so using the rules that we've learned in those examples, I'm going to cut this in half. I want you to try this one and this one on your own. You can stop the video and try it using those rules that we've just discussed. And then once you attempt the name, use pencil, then keep playing the video and see if you get the right answer. Okay, so with this first example, we want to find the longest carbon chain. And I don't want to go across. Going across gives me 5 carbons, so I don't want to do that. But going this way, 1, 2, 3, 4, 5, and 6 gives me a longer carbon chain with 6 carbons. I want to number the chain from the side closest to the first branch. So I have a branch over here and I have a branch over here. And it won't matter which side I number from because it's either 1, 2, 3 carbons to the first branch or 1, 2, 3 carbons to the first branch. So because it doesn't matter, we'll just start from left to right. So 3, 4, 5, and 6. So you have methyl groups, right? These branches right here are methyls, and they are sitting on carbons 3 and 4. So we're going to write 3, 4, and there's 2 of them, dimethyl, and my longest chain is now a hexane. Okay, here is a line structural diagram. If you don't like them or you're not comfortable with them yet, put little dots in. Okay, so there is a carbon chain, and then there are some extra carbons that are attached. So looks to me like the longest carbon chain goes straight across. This is obvious. I think the longest, or the side closest to the first branch, is the right side. So we're going to number from this side. 1, 2, 3, 4, 5, 6, and 7. These are 1 carbon branches. So they're both methyls, and they are sitting on carbons 2, the comma, 2, 5, dimethyl. And then my longest chain is 7. The root for 7 is heptane for an alkane suffix. Let's keep going here and let's do the next one. So right here, this one has a longest chain that is going straight across. You can kind of tell. And we want to start numbering it from the side closest to the first branch. So we're going to number from this side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have a 10 carbon parent in this case. Now we have a bunch of different branches. Here is a 1 carbon branch. Here is a 2 carbon branch. Here's also a 2 carbon branch. And here's a 3. So again, initially with these lines, you want to probably draw the dots in and then circle those branches so that it's obvious to you where they are and where they're located. Now, the thing with branches, when you have more than 1 branch that is different, you place those branches in alphabetical order, not numerical order. Okay, so what we know is that this is called a methyl. A 2 carbon branch is called an ethyl. And then a 3 carbon branch is called a propyl. So what we'll do is we will list the alphabetically lower branches first. So I'm going to draw or write the name up here. I have ethyl groups sitting on carbons 4 and 7. So we're going to say 4, 7, and I have 2 of them. So we write diethyl. And that prefix of di, tri, those do not count in the alphabetical order. It's the name of the branch itself. Then I list the next branch in alphabetical order, which is the methyl. The methyl is sitting on carbon 3, so 3-methyl. The propyl is sitting on carbon 6, so 6-propyl. That's it. Oh, I'm running out of room here. Sorry. That's it for branches. And now I list the parent, which is called a decane. Okay. And then you try this last one here, and then again, stop the video and come back with the name once you've tried it. So when we number this one, we either can number 1, 2, 3 for the closest branch, or 1, 2, 3. And when it's a tie like this, we go, and the branches are different. Okay, so notice I have an ethyl here and I have a methyl here. When you have a tie like that to the closest branch and they are different, you use alphabetical order to break the tiebreaker. Okay, so what will happen here is we are going to number from the left to the right simply because of alphabetical order. So this will be 4, 5, and 6. And then we're going to place those branches in alphabetical order. So it'll be 3-ethyl will come first. And then I have methyls here on carbon 4 and carbon 5. I have 2 of them. So we write dimethyl. And then my longest chain is 7 carbons. So we have a heptane. You can also have alkanes or branched alkanes that are cyclic in structure. And so here are two examples of cyclic molecules. Remember, every point refers to a carbon. And so when you have a cyclic molecule or a ring structure, the parent chain automatically is the ring structure. Okay, so we have 6 carbons here in this ring structure. We know that this 6 carbons would be a hexane. It's all single bonded. But because it's a ring, we have to put in the word cyclo. Okay, and that's really important that you write in the word cyclo. Otherwise, you would write out a straight chain with 6 carbons. So then you've got these branches attached. And what we want to do is we want to number these branches to put them in the lowest position order. So for example, if I started at the top here and I said 1, 2, 3, 4 to get to my branches, then I would have branches sitting on carbon 1, 3, and 4. Okay, so I have branches on 1, 3, and 4. And you say to yourself, well, can I number those and get those branches into a different order that is lower? Okay, and you can. So what I would probably do is do this 1, 2, 3, 4, because you can start numbering anywhere. Doesn't matter where you start numbering. And then that puts my 3 methyls at carbons 1, 2, and 4. And I cannot get anything lower than that. Trimethyl, and then methyl, and then cyclohexane would be the name of that. This other example that's here, I only have 2 branches. So it can either be numbered 1, 2, or it could be numbered 1, 2, right? It doesn't matter, they're equal. But we know what's going to happen here. We have different branches, so the alphabetical order rule is going to take place. So we're going to start numbering the ethyl first because of alphabetical order. So what will happen here is we would have a name of 1 ethyl, 2 methyl, and then the parent is cyclohexane. So you have some structures in your booklet that you can try to draw. And once you do that, come and find me and I will check them for you.